Hi, so this lesson is just introducing you to tree diagrams if you have never seen it before. So what we're going to have a little look at first is this problem solving question. It was taken from one of the DP papers, but I thought it'd be a nice question and challenging one to try right now. So pause it if you want to go, and then I will go through it. So here we have 150 students and they're asked which beverage they like, coffee, tea or a juice. And then the following come in. So if we fill in as we go, 4 like only tea, so we can put that in that section. 2 only like juice. 1 doesn't like any of the beverages. Then it says 35 like coffee and juice. Before we can fill this in, we need to have a little look at what is left. So it says 30 like all 3, so that goes in the middle. It's this one. Then we can go back to the 35. 35 like coffee and juice. That means only 5 like just coffee and juice. Then it says X like tea and coffee. So there's already 30 in that section. So you put X, subtract 30. And then the last point says the number of students that like coffee and juice only is half the number of students that like coffee only. So that means if that's 5, that is going to be 10. Okay, that's all the information we can fill out at the moment. Then the next question says the number of students that like tea and coffee only is equal to the number of students that like tea and juice only. So that missing space here, that's also going to be X minus 30 because they are the same. Now that's enough information to work out what X is. So we're going to add all the sections together. Ran out of space, plus 4 I think is the last one. So we are going to be left with, that will equal 150. So if we add all that together and simplify, we are going to be left with 2x. What am I doing? What am I doing? 1, 30 minus 30 plus 4. Minus 8 is 150. So 2x is 158. So x in this question is 79. And that is the missing number. So if you can make out each section, so the first one, they are going to be the same. So 79 minus 30 is going to give you this section that is missing here. It would be 40, it's not asking, but it'd be 49 for both of them. Okay, right, what are we moving on to today? There's the answers. So tree diagrams. So when we are moving on to obviously the probability questions, probability comes up most of the time when it comes to e-assessments. I think it's in most of the past papers in some form, whether it's a tree diagram or a Venn diagram or just a probability question. So there's different things that we need to know about probability. We've got experiment probability, so that's things like flipping a coin, tossing a dice, things like that. We'll use things like what is the outcome from a single trial. There's a sample space diagram, which we'll look at eventually. It's super easy. We'll say things like event, the probability, independent events. On the right-hand side, there's things like dependent events. So that means that one outcome is affected by the other. We spoke about conditional probability, and we're going to have a little look at tree diagrams, okay? So if we just move on, what is a tree diagram? So a tree diagram is an easy way of organising the probability of things happening, okay? Most probability questions can be done with a tree diagram when there's some events that are happening either like after each other or if they are conditional and things like that. It's a good visual way of viewing a probability. You can do probability in fractions and decimals. You can also do percentages because they can all be converted into each one. So let's go and have a look at a tree diagram. So a tree diagram in this case, it's like a path. That's how I like to envision it. So in this question, it says, okay, a spinner is spun twice. So that's why there is two tree diagrams. So this is our first branch. So that would be spin 1. And then this is our second one, which is spin 2, okay? It makes sense that there's 2 on the second one because depending what your first one is, there's different outcomes that can actually happen, okay? And then it says it lands on red or it can land on blue and then complete it. So it started and gave us some of the tree diagram. So the probability that it lands on a red is 1 out of 5. So that means the probability that it lands on blue is 4 out of 5 because each branch has to equal 1 because that's what probability is out of, okay? Now you think about the outcomes that can happen. If this is spin 1, you could land on a red, spin it again, and you could land on a red. So your outcome could be red and then red, okay? If you spin red on the first one, you could possibly spin blue on the second one. So your path, it's like a path, that's spin 1, that's spin 2, okay? And that's why it's a good visual tool. If you do a blue first, you could then do a red second. So your outcome would be blue, then red. And then your last one that you can do could be blue and then blue. Ooh. So blue and then blue. So in this question, there's 4 different outcomes that can happen. Okay, 4 different outcomes. So, because in this question, the spinner is not affected by anything else, you just spin it each time, the probability on the second tree should be the same. So a red is a fifth, a blue is 4/5, a red is a fifth, a blue is 4/5. So then if it says, okay, we want you to work out the probability of that happening, you times the branches together. So the first one is a fifth times a fifth. So that would be 1 over 25. The second one, a red and then a blue, is a fifth times 4/5, which is 4 over 25. A blue and then a red is 1/5 times by, no it's not, 4/5, sorry, times 1/5, which is 4 over 25. And then your last one is 4 over 25, 5, sorry, times 4 over 5, which is 16 over 25. We know that probability should add up to 1. So when you add all them together, 1, 4, 4, and 16, it should equal 25 over 25. Okay, that is a complete tree diagram done. Then it might ask you questions to work out the probability that both spinners will land on a blue. Well, you can clearly see a blue and a blue. The probability of that happening is 16 out of 25. And you would say 16 out of 25. Okay, the last thing I want to show you in this video, there's a couple of other questions to look at. So this is just an example of it in a decimal. But the question that I want to go and look at is this one. So a conditional one. This is dependent on the other. So 9 sweets are in a bag. 3 of them are mint. So that's why that's 3 over 9 for a mint. And the remaining ones are chewy sweets, or chew sweets. We're going to take one at random and then it's eaten. And then we're going to pick another sweet. Okay, so this one event depends on the other. So again, if we're eating them, we can still get a mint and a mint and a chew and then a mint, or a chew and chew. Okay, so to complete the first one, you've got 3 out of 9 and 6 out of 9. The second tree you have to think about now, okay? So if you eat a sweet, that means your denominator on your second tree is only out of 8 this time, okay? But what goes on the top? Well, if you eat a mint first, you only have 2 left, but you still have 6 of the chews left. But if you eat a chew first, you still have 3 mint left, but now you only have 5 chews. Okay, so that's something to look out for when you are doing conditional probability. And we'll